Hello, this is Mr. Hansen. Today we're going to look at a different way to solve a system of equations. It's called elimination because we're eliminating one of the two variables that we're working with, and sometimes we call it linear combinations. These are the names it goes by. Okay, let's take a look at just a couple of concepts you need to understand before we even really start this. First concept, 1. Multiplying an equation on both sides doesn't change its value. Let me show you what I mean by that. Let's plug in some numbers for x and y here. If I plugged in a 0 for x in that first black equation, then y has to be 4 times 3, 12. If I plugged in 0 for y, then x has to be 2 times 6, 12. And there are probably a few other combinations in here. Let's plug in 2 for x. So we got 2 times 2 is 4. Plus 8, so 4 times 2, so 2 and 2 is kind of another combination. Okay, so that's the black equation. Look how I got from the black to the red equation. I simply doubled every single thing all the way across the board, left side and right side. And if you think about it, if you double both sides of an equation, we've times both sides of an equation by a number before, and they're still equivalent. So they're still equal to each other. And let's see what happens when we plug in some numbers. Let's plug in 0 for x. Let's do it in red. Sorry. Plug in 0 for x. 8 times 3 is 24. Let's plug in 0 for y. 4 times 6 is 24. And finally, let's plug in 2 for x. 2 times 4 is 8. Subtract that from 24, you get 16. And y's got to be 2. Notice that all of the numbers are the same for both the black and the red equation. So technically we can write this equation any way we want to. We just multiply it by any number we want. Let's just try a few. What about this one here? How about 6x plus 12y equals 36. Hopefully you're seeing right there that this is going to give me the same exact thing. Let's try another one. Instead of multiplying by a whole number, let's multiply by a fraction. How about a half? Half of 2x is 1x. Half of 4 is 2. And half of 12 is 6. So again, this equation, just like the other three, they'll give us the same ordered pairs. If you were to graph these equations, they're all the same. They'd be the same on a line. They have the same solutions. So that's the first big concept, is you can multiply both sides of an equation by the same number, and you still, for all intents and purposes, have the same equation, the same sets of ordered pairs, the same inputs compared to their outputs. That's number one. Number two, when you add a system of equations together, the sum of the two equations and one of the original equations will give you an equivalent system. Let me try and explain this. And I'm going to erase a little bit of what I've got here so you can see it as we do it. Okay, let's start with x plus y equals 4. Well, I would probably just put some x and y intercepts there. So when x is 0, y is 4. And when y is 0, x is 4. And so you have an equation that kind of goes like this right there. That's x plus y equals 4. Okay, let's try x minus y equals 2. We're going to do some intercepts again. So when some y is 0, x is 2. And when x is 0, y is negative 2. Let me do that again. Oops. Okay. When x is 0, so we're on the y-axis, y is 2. And when x is 0, I'm sorry, y is negative 2. That was the problem. X is 0, y is negative 2. And when y is 0, x is 2. So it's like this. Okay. So you can kind of already see the solution to this system of equations. We've talked about graphing before, and where the points intersect is your solution. But I want to add these two equations together. So let's add this whole left side. I get 1x plus 1x is 2x, and y minus y cancels out. And then we've got 4 plus 2 is 6. So I've got a new equation now. 2x equals 6, based on the adding the old equation together. So if you think about it, we're just taking an equation, we're adding the same thing to both sides, because x minus y is the same thing as 2. And if I were to graph this, 2x equals 6, x is 3. So the graph kind of looks like this here. And so what we're saying here is, this is a little more simple equation. That's kind of what we wanted so we could solve for x. But what we're saying is, if you add any two equations together, and it's easiest when it's in standard form, if you add any two together, the sum of those two equations and either of those two equations will make a newest system with the same solution. Notice how all three of these lines go through the same point. So if I were to get rid of this line now, x minus y equals 2 and 2x equals 6, I still have, didn't mean to do that. I still have the same solution, okay? Or I could get rid of the other line right here, and I'd still have the same solution. So these are two kind of big concepts that are important. Let's go ahead and try and solve a few equations using some of these rules here. Okay, number 1 says x plus y equals 63 and x minus y equals 27. If you want to think about it in more of a context, think of it this way. Add two numbers together, you get 63. Subtract one from the other, you get 27. So that's kind of the idea there. Now I'm going to do what we learned, that last rule. I'm just going to add these two together. And I got 2x. Let me give you 2x. And the y's cancel out, which is kind of nice, equals 6 and 2, 90. 2x equals 90. Now this is an equation. This is what I'm talking about. This is easy to solve. Just divide by 2. And we know x is 45. Okay. Now let's plug that 45 back in. Let's plug it in right here. So we've got 45 plus y equals 63. And now this is a pretty easy equation to solve too, so I'm going to subtract 45 from both sides. And we've got y equals 13 minus 5 is 8, 5 minus 4 is 1, 18. So 18 and 45 are the two numbers that when added together give you 63. And when subtracted, 45 minus 18 gives you 27. We to solve this, we kind of used that idea of adding two equations together, and we came up with a third equation. It's also a solution to the system, and the third equation was much easier to solve because we only had one variable. So let's try the same thing with number 2. We're going to add, so we got x plus 3x plus 2y minus 2y. We got 4x now equals 8. And if we divide both sides by 4, x is going to be 2. And once we know x is 2, we can plug it back in right there. So 2 plus 2y equals 10. We're going to subtract 2, 2y equals 8, and then divide by 2, and y is 4. 2 comma 4, that's your answer right there. X is 2, y is 4. It's always good to check your answer. If I plugged in 2 for x and 4 for y there, you'd have 10. If I plugged in 2 for x, that's 6, and 4 for y, that's negative 8. 6 minus 8 is negative 2. So it works. Okay, let's take a look at one that's maybe a little more difficult, a little more complex. 2x plus 3y equals 13, and 5x minus 9y equals 17. I could do what I've been doing. I could add these two equations together and get 7x minus 6y equals negative 4. But I still have two variables, and so that doesn't help me a whole lot. So before I add the two equations together, I'm going to think about maybe finding a pair of opposites. So when I add them up, a y or an x cancels out. So I'm going to rewrite this first equation. I'm going to bring it down here. And I'm going to times it by 3. So I get 2x, we times it by 3, that's 6x. And 3 times 3, that's 9y. And 3 times 13, that's 39. So you may be wondering why I times it by 3. Hopefully you can start to see that when we add this up. And remember, the first equation and the last equation are really the same thing. They have all the same solutions. So let's add up the second and third equation. We've got 11x. And look what happens to my y's. Negative 9y plus 9y. I planned that to happen by timesing by this 3 here. I planned for that. So they cancel out. Equals 39 minus 17 is 22. And now that's an equation that I can get my hands on. Just divide by 11, divide by 11, and x is 2. Okay, once we know x is 2, we can plug in x to any of these 3 equations. Doesn't matter which. And we should get a solution. So let's just go for the top one. 2 times 2, that's 4, plus 3y equals 13. Subtract 4 from both sides, you get 9, and then divide by 3, you get 3. So 2 comma 3 is the solution. Now let's just plug it in to all 3 to see that it works. 2 times 2 is 4, 3 times 3 is 9, they add up to 13. 2 times 5 is 10, negative 3 times 9 is negative 27, adds up to negative 17. 2 times 6 is 12, and 3 times 9 is 27, adds up to 39. Okay, we've got one left. This one maybe a little trickier. I want to rewrite my equations so I have a pair of opposites, and I'm not seeing an easy way out like I had last time. This time I'm going to have to rewrite 2 equations. So I think what I might do is I might think about 6 and 8, because 6 times 4 is 24 and 8 times 3 is 24. So I'm going to times the top equation by 4. That's 28x plus 24y equals negative 8. And then I'm going to change colors with my pen, and I'm going to multiply the bottom equation by, I want a negative 24y there. So I'm going to multiply it by 3. So 5 times 3, that's 15x. Negative 8 times 3, that's negative 24. And last one, 6 times 3, that's 18. Okay, now that I have these 2, I can go ahead and start thinking about adding them together. So I've got 28 and 15, that's 43x. And 18 minus 8, if I did that right, that's 10. I'm hoping I did this right. Times by 3, 15. 43x equals 10. And the 24y and the 24y cancel out. And then I just divide by 43 to get 10 over 43. That should be my answer for x, unless I made a mistake. I may have made a mistake in there because I was hoping for a whole number answer. Maybe you can walk through that one and see where the mistake was. I'm going to leave you there. Hope this helped you with solving systems of inequality or systems of equations using elimination. Thank you.